Welcome to another unit in this ISM Statistics 1 exercise set. This time I'm going to talk about the construction of box plots and the calculation of the statistics which we require for the construction of the box plot. So first we have here our data set, 12 observations describing the daily output over the course of 2 weeks. Our task, well, prepare a box plot based on the data set. And that's what we're going to do. For this, we first copy our data set and then arrange this data set in an ascending fashion. So from smallest to largest value. So we take all the different values, always going to the next largest value, order them. Then our first value in the data set, here in this case in the upper left, because I cannot put them all into one row. The first one, the smallest value, and the last value, the largest value. And this will help us immensely in calculation of the respective statistics in the next step. However, first we copy this ordered data set. Then, if we prepare the calculation of the box plot, we can start with the first simple statistic, which is just the minimum. The minimum is the smallest value, so since we have an ordered data set, it's the first value in our ordered data set. That's already pretty easy. However, the next one is a bit more tricky. Here we need to calculate the first quartile. The first quartile, that's also the 25% percentile. So what we do here is we first take the 25%, so 0.25, multiply this with the number of observations, here 12 observations. If the result is an integer, as is the case here, this being 3, then we need this particular formula where we first observe the value we get, so x3, and then we add to the 3 one more. So we go to the next observation and we take the average of these two observations. That's whenever we have an integer result. If it's not an integer, we have a slightly different formula for quartiles and for, in general, any type of quantiles. So here we get 0.25 times 12 is 3. Next one is 4. So we select the third and fourth value, take the average of 200, 210 is 205. That's the second value. The third value is the median. Here again, if we have an even number or an odd number, we have different formulas. In this case, we have an even number with 12 observations. So we need this formula where we have the number of observations, the 12, divided by multiplied with 1/2, giving us 6, the first observation, and 6 plus 1, 7, the second observation we need, and then we take the average of these two observations. Or in other words, if we have an even number of observations, we take the middle two values and get the average thereof. Here we have 230, 240, the average being 235. That was the median. The third quartile again is similar to the first quartile, the only difference being here we work with 0.75. Again, however, 0.75 times 12 is an integer, so we use the same formula as before. 0.75 times 12 gives us 9, the next one being 10. So we select the 9th observation, 280, the 10th observation, again 280, take the average thereof, giving us, well, 280. And therefore we have the third quartile. And finally, for the fifth statistic, we have the maximum. Maximum, the largest value. So well, that's pretty easy again. That's the last value in our ordered data set. This gives us the 5 statistics we need for the box plot. So the only thing left to do is actually construct this graphically. So we prepare a diagram. Here on the y-axis we have the values also from the data set. And then the box of the box plot has as a lower bound the first quartile as an upper boundary, the third quartile, and a line in the middle, that's the median. Also, it might have in the upper part and in the lower part these small lines. Those ones we call antennas or whiskers. And they describe in the lower part the minimum, in the upper part the maximum. Well, that's everything we need to know to construct a box plot based on these 5 statistics we get in a relatively easy fashion from our dataset. Well, this already then concludes the session, so I hope you enjoyed it. I'll say goodbye and see you next time.